let's move to question number 8. All right, so find the maximum, and absolute minimum values of f of x on the given interval 3 plus 81x minus 3x cubed. So in question number 4, sorry, we found the local maximum and minimum values, all right? So the difference between this question and the question number 4 to question number 8 is that we're finding the absolute maximum and absolute minimum of a single variable function. And the reason why we can find the absolute maximum and absolute minimum because we're given an interval, all right? So in multivariable functions, if we're giving an interval, there may be possibly an absolute maximum or absolute minimum within a given interval, okay? Without this interval, we might be looking at local maxes or local mins, or absolute max or absolute mins, depending on what the function is, right? But since it gave us the interval, we can now call it, instead of local, and we can call it absolute max or absolute min, okay? So the junior tutor laid out the strategy of solving these kind of questions. First of all, we need to verify if the function is continuous on interval a, b, okay? If there's any discontinuations or any jumps or any holes, this would make our solution invalid because there might be values that it might not be continuous on this interval, basically, right? So we need to make sure that it's continuous, first of all. So we need to find the critical points of f of x at a and b. So that requires us to find the derivative of our function, setting it to 0, and finding the values of x that will solve that equation, okay? So then after we find our critical points, we need to plug those critical points or those x values back into our original functions to evaluate whether or not they're maximum or minimums. We also need to test intervals here because the intervals are not going to be included in our critical point values, right? But however, they could still be absolute maxes or absolute mins. So we still need to check our interval of 0 and 4, right? And after that, we can finally identify what is our absolute maximum and minimum within our graph and this interval, okay? So first of all, let's verify the first step here, okay? So the first step is to figure out whether or not this function is continuous on the interval, all right? And a quick look at the graph will show us that this function is continuous on all real numbers, okay? We see here that there's no denominator that will make equal to 0. We also see here that there's nothing that goes to infinity here, right? This is just a polynomial. So we know at all x in real numbers, in the real number set, f of x is continuous, right? You guys can check this. You guys can also graph this. It's a very excellent way of seeing if it is a continuous function by just graphing it, okay? So we need to find the critical points now. So we need to calculate f prime of x, okay? So f prime of x will be equal to 81 minus 9x squared, okay? We want to factor that, which is just x squared minus 9. Okay, so, and that is just equal to negative 9x plus 3, x minus 3, okay? So now we need to set f prime of x to equal 0, which sets this equation to equal 0. And now we need to find our zeros, right? So our zeros here are x equals 3, negative 3, okay? So we have found our critical points. So we have found out that there's a 0 rate of change, or there's a 0 slope, or at x equals 3 and x equals negative 3, okay? So now the third step is to evaluate these critical points and intervals. So evaluate f of x at 3, negative 3, and we need to check our intervals too, so 0 and 4, okay? So f of 0 would equal to 3, okay? F of, whoops, why do I have a bracket here? F of 3 is 3 times 81 times 3 minus 81, which is 165. I'm just looking up the thing. And And we're also going to evaluate f of 4, which is equal to 135. Okay? So you're just going to plug in those values. And the reason why we did not evaluate -3, even though it is a critical point of this function, is because it is not in the interval of 0 and 4. So we don't need to calculate it, okay? So finally, we have our 3 points, and we can now identify what is a local maximum, or absolute min, okay? So this here is our absolute min. And 165, or f of 3, is our absolute max. Okay. So finally, we can write our concluding statements. So f, let's just write 0 and 3 is our absolute min of f of x, and f of 3, oh, why do I keep writing f? And 3, 165 is the absolute max of f of x. Okay? So this was the step-by-step strategy of solving these kind of questions. And you guys will really encounter a lot of these kind of questions because they're very simple, but they test a lot of core principles and theories. Okay, so this solution is correct. Good work. Okay, cool.